The purpose of this video is to do a couple of examples of taking a trig equation and basically graphing it. This actually is a copy of the homework that you're going to have to do. In this class, as you know, almost all the homework is done online. But since it's not really possible to graph online, we give this assignment as an old-fashioned assignment where you have to print this out and do the work and then scan it and turn it in as homework. So there are actually going to be this is the actual assignment. There are 5 different trig equations that you're going to graph. And I'm just going to do a couple of examples since you've done a lot of this stuff already in the homework, but you haven't obviously graphed. And it's important in trig to be able to create these graphs, so this is why we have you do this kind of assignment. So I am not going to, this is the problem you're given. I'm going to slightly change it. Instead of this, I'm going to say y equals 3 cosine of 2x. Now the first part of what I'm going to do is stuff we've already done before, because what I'm going to do is I'm going to go ahead and determine the amplitude, period, and phase shift, because this is information I'm going to need to graph this equation. So as you know by now, we have the standard equation for these trig functions. And in this case, A would be 3, which is going to be the amplitude. The period is based off this omega. So omega is 2, and the period is this little formula, 2 pi over omega. So the period is going to be pi, and you can see here that there is no phi, so there's not going to be any phase shift. Actually, the formula for the phase shift, which we will use for the next problem, is phi over omega. Now here's how I go about graphing. Now this one is not going to be too hard, because this is, you hear me say this again later on, this I call a graph with no phase shift, and these are pretty easy to graph. The thing I always start with, I always look at my period. So here's my graph. So here's angle 0. A period means one cycle. So the period, and when you create the graph of a trig function, what they want you to do is to create a graph where you have at least one period. So at a minimum, I need to create the graph between 0 and pi. Of course, you can extend it if you want, but I need to show the graph between 0 and pi. Now what you do, anytime we do a trig function, a graph, like if we're going to do the cosine starts high, and it goes to the middle, and then it goes low, and then it goes back to the middle, and then it goes high again. So this is one cycle. So here is one period. Now what we like to do is we like to break this period up into 4 equal parts. It starts here. Here's the first part. Here's the second part. Here's the third part. So these are 4 equal regions in terms of the width of each region. So what I'm going to do is I want to figure out these 4 regions here, And once I do that, it's pretty easy to create the graph. So I know from 0 to pi, I'm going to have these 4 equal regions. Sometimes it's pretty easy to tell, but a lot of times I will write this. And this is just my little, this isn't in the book or anything, this is just my little terminology. I call it the 4 key point separation. In other words, how far is it between, how wide are these 4 little regions here? And the way you get that is you take your period, whatever your period is, and divide it by 4. Since we have these 4 regions inside of one period, obviously we divide the period by 4. For us, the period is pi divided by 4. So what that means is I go down here, and now just in case you can't see this graph, this is 0 here, this is pi. What I do is, you can see here, I go and I just put a dot here at the end of my period, and then I cut it in half. In other words, from 0 to pi is my period. Halfway is pi over 2. Now from 0 to pi over 2, I cut it in half again. Now half of pi over 2 is pi over 4. And then between pi over 2 and pi, I cut that in half. And this actually is going to be 3 pi over 4. Now what you can see is, from 0 to pi over 4, from pi over 4 to pi over 2, pi over 2 to 3 pi over 4, 3 pi over 4 to pi, each one of these regions, the width of each region is pi over 4. So basically, you don't even always need to do this calculation. A lot of times I will just graph the period, you cut it in half, then you cut that in half, and then you go here and you have your regions here. And then for a cosine, when the angle is 0, the cosine always starts high. Now the amplitude is 3, so 3 is right here. So when the cosine is 0, here's my starting point. And what happens is, at this first point here, it goes to 0. Then at the next point, it goes down to your lowest point. And then you're back here, and then you go back to the high point. And then you can try and sort of sketch in this case, one period of the cosine function. So this is a cosine, starts high, goes low, finishes high. Amplitude's 3, right? Goes from 3 to 3. In case you can't see, this is 2, this is 4, this is 0. So it goes from 3 to negative 3. And the period is from 0 to pi. So really the whole key is, once you find your amplitude and your period, then you can pretty easily sketch this in. Now just for fun, you're going to have a problem where they add what's called a vertical shift. So let me take this original equation and I'm going to add a vertical shift. The equation now becomes, matter of fact, I don't know if you can see these colors. I'll do this in red because I'm going to do another graph on here with a vertical shift. So the first part's the same. A vertical shift is just when at the end you add or subtract a number at the end. The reason it's called a vertical shift, what that's going to do is then you're going to take this original graph and we're going to move the whole thing up 1, since it's a positive 1. If it was a negative 1, you move it down 1. If it was plus 2, you'd shift the whole graph up 2. Now once again, if I'm going to graph this, what I do is I ignore the vertical shift at first. So if I was trying to graph this problem, I would ignore the vertical shift and do the graph of 3 cosine 2x. And then I'm going to come in and now simply move this whole graph up 1. Now what I do is I will take my key points, like this one is going to go from here to here. This point is going to go up 1, which would be here. This point to move up 1 is here. This point it gets moved up here. And this point it gets moved up here. So I did these like these circles here. And now I can try and draw a graph through these new points I just created. So this red line is the graph of 3 cosine 2x plus 1. And this original graph, the blue graph, is the graph of y equals 3 cosine 2x. This is the kind of thing you also learned in algebra, shifts and transitions. So you will actually have, I think one of the problems has, look at this one, 4 cosine x minus 1. So the vertical shift is going to be 1 in the negative y direction, moving down. Now the reason why this problem isn't too bad is because there's no phase shift. Usually when you're graphing trig equations, the phase shift is where it gets a little tricky. So let me do a graph now where there is a phase shift, and let me just show you how I do it. In math, there's always different ways to do things, but let me just show you the way I do it. So here is the problem that you're going to do, and I'm going to change this. It's going to be pretty similar. I'm going to instead do 2 sine of 1/2 x plus pi over 4. So ultimately I want to graph this equation, and of course I'm going to have to figure this stuff out in order to create my graph. So of course the starting point is, once again, to figure out the A, the omega, and the phi, and you've done this before in problems, so this is nothing I need to talk about very much. So A is 2, which is going to be the amplitude. So on this graph, 0's here, 5 and 5. So 2, and then down here, sort of hard to see actually with this printout, but we'll just assume it's right about here. So my graph is going to go between -2 and 2. Now if I want to know the period, omega is 1/2. So the period is 2 pi over omega, this is a formula for the period, 2 pi over 1/2. If you simplify this fraction, you get 4 pi. So sometimes what I do is I just go ahead and if I'm going to draw one period, I'm going to go from 0 to 4 pi. And now I want to have my 3 points in between, so I cut this in half, and then I cut that in half, and I go here. So here are going to be the points, the main points, when I get ready to draw my graph. Now what I'm going to go ahead, matter of fact, I'm not even going to work with the phase shift yet. Here's the way I do it. If I have a phase shift, I'm going to instead initially go in and I'm going to create the graph with no phase shift. I mean, this is just the way I do it, the way I think it's easiest. So I know, since I have a sine, when the angle is 0, the sine is 0. So a sine graph starts here. At my first point, it goes high. The next point, it goes back to the middle. The next point, it goes low. It's sort of hard to see here. Then back to the middle. And then it goes high again. So what I'm going to do, I'm going to go and sketch this graph, although you'll notice I'm going to sketch it with a dashed line, because this is not going to be the final answer. This is not the final graph. This is like an intermediate graph. So this isn't going to be the best looking graph, but you know what? I think I messed this up. Starts here, goes high, back to the middle, low, oh, you know what I did? This point's wrong. Wow. It was supposed to be here. Sorry. And that point's wrong too. Matter of fact, if I had another piece of... Actually, you know what I'm going to do? I'm going to redo this, except I'm not going to use this graph. On this homework, if you don't want to have to print this out, you can, you've seen me do this in videos where you sort of create your own graph. So I'm going to do that, since I butchered this pretty good. So once again, here's going to be my graph. And I'm going to go, and here is going to be my period's 4 pi. So halfway is 2 pi. Half of that is pi. Here is 0. And then 3 pi. So if you don't want to have to print this out, you can just write down the formula or the equation, give the information, and just do the graph like this. That's fine. So once again, the sine starts low, goes high, back to the middle, goes low, back to the middle. So once again, I'm going to do it in a dashed line because this is what I call the no phase shift trig graph. So you can see the amplitude is 2, period is 4 pi. This is the sine wave, no phase shift. Now, let's go figure out what the phase shift is going to be. And once I figure out the phase shift, then what I'm going to do is, then I will shift this graph to include the phase shift. So the phase shift is based upon knowing phi. This is a little tricky, but we've done this before. Since this is a positive power over 4, actually phi is negative power over 4. And then the phase shift is phi over omega. So phi is negative power over 4. Omega is 1/2. When you simplify this, you get a phase shift of negative pi over 2. So what I do now, so now I'm going to take my no phase shift graph, and I'm going to move it, in this case, since it's a negative pi over 2, I'm going to move it the distance pi over 2 in the negative x direction. So here's what you do. First of all, what is the distance pi over 2? Well, if 0 is here and pi is here, here would be pi over 2. So I'm going to take this whole graph and shift it to the left this distance. So let me do it in red again, so maybe it's easier to see. So I'm going to take my key points, and I'm going to move each of the key points pi over 2 to the left. In other words, this point is going to go here. This point is going to go here. This point goes here. This point goes here. And this point goes here. And now I'm going to draw a graph where I connect these points. And that's going to actually be the graph of my equation. So you can see that if you look at this, for my no phase shift graph, I basically move the whole graph to the left by pi over 2. So therefore now this graph here in the red, I could say this is the graph of y equals 2 sine 1/2 x plus pi over 4. I think my pen is running out. So that's how, for me, that's what I think is the easiest way to create the trig graph when you have a phase shift. Just real quick. Once I got the amplitude and the period, I went ahead and made this graph a dashed line, which is the no phase shift graph. And then when I determined the phase shift as negative pi over 2, then I take my no phase shift graph, and in this case I moved it to the left pi over 2 in order to get the graph of my equation. All right, so in this homework assignment, you're going to have 5 of these graphs to create. Hopefully you'll be able to do them well. And this is something you need to be able to do, so hopefully this will help.